Hello all. Today we are solving LeetCode problem number 3643, flip square submatrix vertically. So you are given an m cross n integers matrix which is called as grid, and there are three integers given, which is x, y and k. The integers x and y represent row and column indices of the top left corner of a square submatrix. So we all know what exactly is a submatrix. So something which exists within a some matrix which exists within a matrix, and which can be rectangle or square, but it should be something which we formed out of a matrix. So that is what we call it as a submatrix. And this x and y represents the coordinates of top left. So if we consider this as a submatrix, so it indicates this position's coordinates and this as well. So k represents the side length of the square submatrix. So here we are considering a square submatrix, so in this case k represents the length. So you have k cross k submatrix, and x y represents the top left corner. So in this case, if you have complete a matrix, so if this is a submatrix, this position is x y, and k is the length of this particular submatrix. So this is about the question which is given. So your task is to flip the submatrix by reversing the order of its rows vertically. So what exactly this mean, we can understand with the help of example 1. So here, flipping the submatrix by reversing the order of its rows vertically means you have to change the submatrix. Flipping means change the submatrix by reversing the order of the row vertically. So you have this row, first row, which has 5 6 7 and 9 10 11 and 13 14 15. So reversing this means this is at third position. Now it goes first and second and third, right? So that is what exactly this means. So based on this, you get the output as 13 14 15 and 9 10 11 and 5 6 7. So this is the flipped submatrix. So that is how you flip the complete matrix. So this is what exactly the output which is required. So from this example it is clear, this is the question all about. So how do we solve it? So first thing is we have to locate the submatrix and then iterate through this, and then we have to swap this row with this row, because the middle one, it is of no use, because clearly here we can see that for this example there is no requirement to swap this, because we have to swap this with this in order to get the output, right? So for this particular problem, this is alone enough, swapping the first one with the last one, which will satisfy all the test cases. So how do we do that? You can iterate, anyway you have to iterate through the matrix, so which consumes for loop I, and for j this is n times column, row, and this is column m. So you iterate, and again you can iterate, or I can iterate for the submatrix. So which means you can iterate the submatrix and then you can swap, which will again consume big O of n square. So in total this will result in big O of n power 4. But there is one simple way of solving this, because we have to consider only the top row to swap with this row, right? This top row swapped with this row. So we have to locate this one and swap it. So that is what we are asked to do. It is required to do to simplify this problem. So hence you can solve the time complexity for this problem within n square time complexity you can solve this problem. It is that easy. So how exactly we can do this? In this example, it's better to go with the example. So let me change the color. So this position is referred by x and y, so which means x is the row and column is y, right? And if you want to locate this particular position, how do we locate it? It's, it is very straightforward because this is of length k, right? So which means based on index this will be 0 1 2 3 and 0 1 2 3. So if this is based on 0 index, hence to locate this particular position it is simple, which is x plus k minus 1, right? So this is how you locate it. But one thing we have to note clearly is you may not know that there may be the if the matrix is bigger, which is of something kind of this, then you have to stop at this positions, right? And while you process it, you have to process that based on the rows. So you have to use the submatrix index as well. So based on this, the submatrix index, this is 0th row and 0th, first column and second column as per submatrix. And for matrix this is 0th row, first column, second, 0th row, first row, second row, third row. But for submatrix this is different, right? So you have to use the submatrix to locate this particular location, which is x plus k minus 1 and subtracted by x, right? Because that is how we will be able to calculate or locate the position. This is not exactly x, this is x of submatrix, right? So this is how we will be locating this position, and using which we can swap it. So using this you will locate this particular element and this particular element, swap, which means you will have 13 here and 5 here, and you move to in the next iteration based on the next column in the jth loop. If based on j you will be moving to the next column, right? So you stay in the same row and you stay in the same column and then rotate it, swap it. So you move here, you move here, swap, you move here, you move here, swap. So that is what exactly here it is happening, and this is the idea which we are going to use to solve this particular problem. And the time complexity for this problem is n square, big O of n square times, and space complexity is big O of 1 because we are doing the changes on top of the matrix only. So with this idea, let us go ahead and code this up. So first thing is we have to locate the submatrix row. So submatrix row, row is equal to 0 initially, and now for you already have the grid and things, right? So now we will be iterating till starting from x till x plus k. So for I in range x till x plus k, and now you have to stop this sub row if you reached till middle. So if it is beyond that, there is no requirement, right? Because we do not need to find if we are somehow reached the sub row, there is no requirement to calculate, right? So in this case we are checking if it reached till half of the position and then we are breaking it. So if submat row is equal to x plus k minus x divided by 2. So if this is the case, then break. Okay, so you break this point, I mean iterating the row actually, because you found the row. So in this case you break it, and then what you do is you start iterating the column, because you need to swap it. So now for j in range, start from y and y plus k, and now you will be swapping. So swapping in Python is very easy, because you have to swap grid of I and j with grid of, for locating it, you have x plus k minus 1. So this is it, and then you have to subtract that by submat and column will be j. So for swapping this in Python, it is simple, which is equal to and grid of I j. So now the swap is done, and the next thing is you have to increment the submatrix row. So increment by 1, so that should be out of this j, the j loop, and now it is done. We have to return the grid. So that is it. Let me run it, and it's working. Submit it, and there you go. Thank you.